Today we're doing a tech session on internal controls, so keep an eye on our website. Later on this week it'll be up there for everybody to view. Check the diameter that the sleeve operates on. This is supposed to be 1-inch diameter or a tad under. Make sure it's round. Stick a set of calipers on it. Over the years these things become tweaked, even just kicking around your shop, which they shouldn't be kicking around, but these can be easily deformed, squeezed in. So a little bit out around here just causes all sorts of problems. So just make sure that they're all nice and round, no burrs. Slide the sleeve on, make sure it all rotates nice and easily. The slot here is a 1/4 inch wide. If it's wider than that, it's going to be sloppy. And the stroke on the slot is to the start of the radius is 2 inches. Now some on the market are less than that. That means that you're not going to get full throttle or proper advance and retard. This is a special tool we made up for assembling block and pins into the inner control cable. This particular one on this side will allow us to press the pin out. So if you're removing it, you can actually set it in there and we can put a pin on the top of here and just press it all the way through. And then for assembling, we use this side. It's got a stopper on it. And what that stopper allows us to center the pin just to cheat away. We do quite a few of these. So here we go. Actually stop. This is a tool that we made up since we do quite a few block and pins. This tool here on this side allows us to push the pin out of the block, and this one here, that allows us to assemble the pin into the block. So it's actually got a stopper down there. It'll center the pin. So we're going to put the inner control cable into the block. It's going to be pointing down. Assemble it like so. Line everything up. Make sure the pin slots are parallel to the outside of the block. As you can see, this one here is cockeyed. All you need to do is get a crescent wrench and twist it so you get alignment to the block. Now usually that's got to be under an interference fit. Just hold it in the vise and give it a little tweak. The other thing is, you see this cable is coming through at an angle. It's not coming out 90 degrees to the block. Just get a pair of pliers and bend that down right at where it comes out of the block, and make sure it comes out at 90 degrees. All this affects a smooth operating control cable. Any little kinks, any misangles, all makes a big difference into the way the whole mechanism works. And then make sure the pin is protruding out evenly from this side to the other side. This is a tool we made up to capture or hold the outer control cable. We've actually got to unwind a little bit of the end right here. So this tool just allows us to hold it in the vise. You can just hold this cable directly in the vise, but just makes it a little bit easier for us. We do quite a few of these. This stops the outer cable from spinning. And what we're doing, we're going to come in and we're going to unwind this outer cable a little bit. So just with a hammer and punch, just unwind that outer cable. What it's going to do is going to capture or lock onto the stop, which we'll show you in the next step. So we need to unwind the outer cable, and that's going to go up against the stop. So you just got to make sure that the stop is captured. And on the other end is going to be a nut that exits the handlebar. So between those two, it can't move. So you can see the end how it's unwound. They pulled right up against that stop. Pull the outer control cable through the handlebars. Line up the slots in the stop, the slots in the handlebar. Make sure that's going to go all the way down, stop on the end. And then just have a lot of patience. You're going to wind the nut all the way on till it goes up to here, to the handlebar. Now, the nut has two different sides to it. It has a nice radius end and it has a square end. The square end goes up against the handlebar, so you see the nice rounded end. That's a left-hand thread. That's original. And just sit there for a while. Wind it all the way on. The cup comes up to here. What that'll do, with the stop all the way in the end of the handlebar, and the nut on this end, it's going to stop. It's going to capture the outer cable firmly, so it's not going to have any backwards and forwards movement. It's very important. So at this end we have the stop properly seated, and this end we have the nut on, and it's capturing this whole cable firmly so there's no backwards and forwards motion. Otherwise, if it does have some backwards and forwards motion, that's where you're going to get some slop in your throttle mechanism. Routing the control cables is important. This particular bike, like most of them, guys set them up with a right-hand throttle, left-hand shift. So you're going to have a right-hand throttle and you'll have a left-hand advance and retard. So run your cables down each side of the shock, but always give yourself some slack. As you can see, this one here is pulled down pretty tight. You want to have a little bit of slack. So when you turn the handlebars from left to right, it's not going to put the cables under tension. You don't want them up so big like this, they look ugly. Just want them down something like that, a nice gentle bend. The left-hand spiral is the advance and retard. It's going to be captured here at the tank, the right side tank, and then down at the distributor with a nut on each side of the L bracket. The throttle cable is captured at the tank bolt and at the cylinder head bolt. So make sure that clamp there is held securely to the outer control cable. If it's not, the control cable can slip and go into a full throttle wide open situation and cause some very serious issues. Before putting the inner cable in, just make sure there's no burrs on the end or kinks, and then insert it through the outer cable. Sometimes you can have a little issue going through the bend here. That's why it's real important to make sure there's no dags or burrs on the end of the inner cable. So fit the block and pin, slide it all the way in, make sure it goes in there nice and securely, easily slides in backwards and forwards. It's part of the pre-fitting actually. Get the block and pin and pre-fit it in the handlebars, make sure it does fit easily. Make sure the block is centered to the handlebar, because when the mechanism, the spiral mechanism goes in here, all this becomes very, very much a tight fit. And that's why the handlebars are not normally, a lot of 1-inch material is 120 thick. That's 0.120 thick. Handlebars on Indians are about 0.085. this allows the whole mechanism to work properly. See, it's going to just slide up and down here. As you can see, these are all original handlebars. They've got a little bit of slop in them. The slot is wider than 1/4 inch, and unfortunately what's going to happen is this is actually going to have, it's going to be a little bit harder to keep a constant throttle on it, because you've got this slack on it, and you want to give it a twist a little bit more to go faster, a little bit less to go slower, and you're sort of in between. So having these slots here a net fit onto the pin is very critical. This is the horn button assembly. This part here is the insulator. It's going to fit down inside the handlebar hole. So it's going to sit down that way. This is the spring retainer, and it sits on top like so. Actually it sits on the seat down there like so. And you got the spring that's going to sit on top, and the button part itself sits on there, and all that fits inside this assembly. So when you're actually pushing down on your horn button, what you're essentially doing is completing the circuit. So it's actually coming down onto the end of the wire there. I'm going to drop the horn button into the housing like so. The spring retainer, it's going to go this way around. And it's just a little press fit into the housing, and holds itself in there. Then this part here will actually go into the handlebar, but it's actually going to essentially contact like so. To get the horn button and the high-low switch wire through the handlebar, just get a piece of tie wire, thread it through from the handlebar from this end all the way through where it exits the horn button hole, and then solder the horn button wire onto it, and then just pull it all the way through. It's pretty easy. Likewise with the high-low switch wire, mount the high-low switch with the 632 screws. Make sure they're not too long. They're only supposed to be 1/4 inch long. If they're too long, they're going to interfere with the wiring, create a short down the road. And the horn button, make sure the little insulating piece is nestled down into the handlebar, and then the horn button mechanism will go on top of that, and just screw that on, and that's 832 by 1/4 inch screws. Make sure the spring retainer sits up against the handlebars right out here. It's necessary in order for it to complete the circuit. On powder coated handlebars, quite often you've got to come back and file a little bit of the powder coating away so it can actually get metal to metal contact. If not, the horn button is not going to work properly. Put it back in there like so, and just press that whole assembly on. You're good to go. There's a left side and a right side spiral. This is the guts that goes inside the spiral. This is the right side, which is the throttle side. So what happens is the pin will be pulling this way. So as you're rotating the throttle this way, if you're accelerating, what it's doing is it's pulling the pin and the inner control cable or throttle cable this way. The left side is actually going to work the opposite way. So as you're twisting your throttle this way, it's actually pulling the pin this way, which is actually pulling the control cable. So as you're rotating this way on the left side, it's actually pulling the cable out. This one is the left side spiral. So the pin would go in here like so. Actually, see, as you twist your spiral, it's pulling the block and pin. That would be retarding it if it was the left side. This would be rotating it, and you'd be advancing it this way. It's pulling the cable out. Put the right side spiral on the right side. And we're just going to do a dry fit, meaning no grease for now. Do up the nut. Now, you can actually see here we've got a lot of play, which the factory never made up shims, but I come up with these shims that you can fit in there, and I'll take up any excessive play. The less play you got there, the steadier your throttle is going to be. You can actually see a little bit of end float translates into a lot of rotational slack. So fit the shims over the bars like so. Put the spiral back on. Actually see you've got no very little end float. Those shims are 5 thousandths each. In this case, took a total of 20 thousandths. You got nice smooth operation and no end float. Now, last step would be to remove the spiral and lube the heck out of all the internal controls there, so the block and pin and the slot, and then the spiral inside here. Just don't be scared to put plenty of grease in it. That's your best friend. Here's another shot of how the spiral works, pulling the block and pin. So as you're rotating it this way, well, let's say you're rotating it, winding the throttle on, it's actually pulling this out. So when you're throttling off, being this way, it's actually going to push this whole mechanism back in, like so. So accelerate is going to pull it out. So you're pulling it, turning it this way, pulling it out, going back this way, throttle off, just pushing it back in. Factory didn't have any particular way, which way was high beam, which way was low beam. I like to put this way for down, low beam, that way for high beam. Reason being is the handlebars go down for low beam and up for high beam.